This is introduction to exercise 5.1 on transformations. Now the idea is that we're going to understand three different types of transformations you guys have already learned about in the past. So our dilation, our reflection, and our translations. Okay? We need to understand the connection between coordinate mapping and to the equation. I'm going to actually present you with two different methods for doing the same thing. Obviously I have a bias, but it's up to you which one you use. Okay? As long as you understand both methods, it's fine. You don't have to apply both methods. Okay, and then later on we're going to apply those transformations and we're going to combine them to have a range of both, of dilation, reflection, and translation. But first we're going to focus on one at a time. The first one I'm focusing on is translation. This is page 6 now, by the way. Translation, now you guys already know it's the sliding of a given point. We translate it right, up, left, down, or a combination of those as well. In the example shown left, we're translating 2 units to the right, 4 units up. Pretty straightforward, okay? Do note that if we translate, we're translating not just the point, but the rest of the points as well. In coordinate form, we write xy. We write that xy goes towards x plus 2, comma y plus 4. Literally, if we have whatever value or whatever function it is, right? If we apply translation of 2 units to the right, it's x plus 2. It's pretty straightforward. Literally. It's a pun about, don't worry. So, if we're applying a positive translation of 4 units upwards, we're adding 4 to our y value. Please note, try your best in an exam or an assessment situation, don't write left, right, up, down. Examiners actually hate that, right? It's not technically wrong, but it's a perspective thing. So instead of saying left, right, in the negative direction of the x-axis, because clearly you guys have a lot of time in an exam, right? And of course, if it's a y value translation, don't write up or down, write in the positive or the negative direction of the y-axis. So that's listed there. Translate in the positive or the negative direction of the x or y-axis. Okay, so again, avoid up, down, left, right, horizontal, vertical. Examiners don't like that. Applying translation to a graph is different how the coordinates change. So if we apply, for example, x, y, and we go x plus 2, same thing, we would translate 2 units in the positive direction of the x-axis and 4 units in the positive direction of the y-axis, it's not just plus 2 plus 4 the entire way around, right? So here we have to substitute our translation in. Okay, so in this equation we have to undo, I'll show you what I mean by this, but we have to undo the translation process and substitute our translation into our equation. Again, I'll go through an example. Here, just in general, just in case you've forgotten it from last year, horizontal translation to the right by h units will map f of x to f of x minus h. Remember, apologies, remember if it's in the x direction, it's the opposite. Yeah, so if we're translating, let's say, 2 units to the right, it's x minus 2. Vertical translation by k upwards will map f of x to y so negative k equals f of x, or we can just write f of x plus k. So that's just a direct translation. Okay, let's get started by doing an example. I'm going to first show you the mapping way, and then I'll show you my way. But again, they're both valid. Okay? So of course, we want to start with x, y. Then let's read the question. Find the equation for the image of the curve. So it says image. We're trying to find the new equation. With the equation y equals f of x, where f of x equals to 1 over x, under a translation, let me get my highlighter out. So f of x equals to 1 over x, under a translation of 3 units in the positive direction of the x-axis, and 2 units in the negative direction of the y-axis. So what are we looking for? We're looking for the new equation under both of these translations. Okay? Can you read that up the back, by the way? Yeah? Okay. So, with this in mind, we start with x, y. Let's apply our transformations. Now, we know that we're translating 3 units in the positive direction of the x-axis. Now, purely looking at coordinates, what does that mean? Are we adding to the x or the y? X, right? Because it's in the x direction. And we're adding 3, aren't we? So that becomes, and we write maps to x plus 3, comma, y. We've translated 3 units to the right. We're not applying the function yet, we're just looking at the coordinates. Now we apply our second translation. This time, 2 units in the negative direction of the y-axis. The negative direction of the y-axis, so we're going quote-unquote down. We're going to shift our y to y minus 2. If you'd like, you're welcome to skip that middle step and jump straight to x plus 3 y minus 2, but I'm just doing this to demonstrate the steps. Any questions so far? I do realize I'm going quite quickly, so please let me know if I am. Next thing we're going to do, we're going to define our translation. So, what I'm going to do is I'm going to write x dash. Now, don't mistake this as derivative. We're just saying this is the transformation, the transformed x. Equals, and we're going to write whatever's inside our x coordinate here. Okay? So we get x dash equals to x plus 3. Next to that, I'm just going to write y dash and the same thing before y coordinate. So our transform coordinate is x plus 3 for x, and our transform ordinate for y is y minus 2. I'm going to rearrange them to get x and y as the subject. Assuming you guys are happy with this, I'm going to write x equals to x dash minus 3, and of course we have y equals to y dash plus 2. Then all we have to do is substitute it back into our original equation. So here is our original equation. So we get y equals to 1 over x, and that is being mapped to, I'm going to replace y with our y dash plus 2 from earlier, which equals 1 over, and replacing x with our our equation from earlier, x dash minus 3, or in other words, y dash equals to 1 over x dash minus 3 minus 2. Now, if you remember your stuff from function families from last year, you'll note that that is a translation of 2 units down and a translation of 3 units to the right. Now, did that seem more complex than it needed to be? Yeah, I think it did, right? Let's look at my method, yeah? And again, as long as you understand where both methods are coming from, it's perfectly fine, okay? So let's look at my method. Oh, actually, sorry, before you do that, I have made a mistake in here, but it's not a process error. In an exam, right, you need to make sure that you clearly define what your variables are. Now, luckily in this case, it does specifically say y equals f of x, so we're good. But if you were presented with f of x, and you just suddenly write y, you would lose marks. Does that make sense? If you're just given f of x equals to 1 over x, and then in your process you write y equals to blah, 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 you will lose marks because you haven't defined y. That's something I'll talk about a lot throughout the year, so I'm just giving you a heads up. Okay, so let's look at our process. We start with f of x. Now we know that if it's translated 3 units in the positive direction of the x-axis, is it going to be f of x plus 3 or minus 3? 3 units in the positive direction. Thank you very much. It's going to be minus, because remember, x-axis opposite. Of course, we're adding 2 units in the negative direction, so that becomes f of x minus 3 minus 2. Any qualms with that? Lovely. And if we substitute our values in, f of x minus 3, we get 1 over x minus 3. And then, of course, we have the minus 2 at the end. Done. Same thing. Both processes work. Personally, I think one's easier than the other. Okay. Are we happy to move on? Any questions about that? Key thing to remember is that the x translations mean that you have to do the opposite. Please don't do the wrong way around. All right, let's move on. Move on to reflections. Reflections. Now, of course, you already know, but note that I'm doing this in opposite order, right? I'm starting from what I believe is the easiest to the hardest transformation. So, translation, reflection, dilation. When you're doing your transformation sequences later on, Note that it's always in the order of dilation, reflection, translation. Or Dr. T, this might be easier to remember. Which is like Mr. T's more educated cousin. Anyway, so reflection. Transformation that finds the mirror image of the points. We usually reflect in the x or the y axis. Sometimes we will also reflect in the in the line of y equals x. Less common, but we'll talk about that later on. Reflection in the x-axis. So the wording here is very important because I feel in transformations it's one of the most difficult things to remember. A reflection in the x-axis changes the y-coordinate. If I say reflection in the x-axis, you treat the x-axis like a mirror. So if I say reflection in the x-axis, you reflect this way. If I say reflection in the y-axis, again, the y-axis becomes a mirror and we reflect this way. If I say reflect along an axis, that doesn't make sense because that's for dilation. But keep in mind the wording, okay? So in general, this is our mapping, our coordinate mapping. xy goes towards or maps x, negative y. In general, y equals to f of x will become negative y f of x or y equals negative f of x. Okay, so that process right there is that general coordinate mapping. You don't need to memorize that, but note that f of x becomes negative f of x. That's a reflection in the x-axis. Let's move on. A reflection in the y-axis changes the x-coordinate of the point. So here, we're mapping x, y into negative x, y. And in general, f of x is mapped to f of negative x. Depending on the order, and later on we'll do a multiple combination of transformations, depending on the order of your transformations determines the sequence in which you should be doing them. Okay? Let's put this into an example. Again, I'm going to do both methods. Let's start with, apologies, let's start with the coordinate mapping. So with coordinate mapping, we're focusing on the coordinates. Let's start with x, y, and then I'll read the question. Determine the rule of the image when the graph of y equals to root x minus 3 minus 4 is reflected in the x-axis. So far, you know it doesn't exactly matter if we know what that graph looks like at the top of our head. Later on, I'll ask you to use your class pad and you double check your transformations. Does it look like a transformation that's correct? Yeah. But for now, let's not stress about knowing what the graph looks like. A reflection in the x-axis. Which way am I reflecting? What's being treated like the mirror in this case? The y point. So the y point's being reflected. Good. So your graph should be reflected this way. Happy with that? Lovely. So, x, y, now we're saying reflected in the x-axis. I'm going to scroll it back up a bit and we can see that if we're reflected in the x-axis, it becomes a negative y. So I'm going to replace that to become x, negative y. Anything else we need to do? Are there any translations or anything like that? In this case? That we have to focus on? Not really. Now, there are transformations from y equals root x, but nothing else we need to do because we are just reflecting. It's deep. So then we write x dash equals to x and y dash equals to negative y. I'm just writing the transformation or transformed x is x, transformed y is negative y. I then go ahead and rearrange them. So that becomes x, actually I'm not even going to bother writing that one, but I'm going to write y equals to negative y dash. I'm going to replace our original equation with our new found variables. So instead of writing y, I'm going to write negative y dash equals to root of x dash minus 3 minus 4. I didn't have to touch the x besides add the dash on because x dash is x in this case. Now, obviously, before I finish off, I should probably write the full equation. So I multiply both sides by negative 1, and it becomes y dash equals to negative roots x dash minus 3 plus 4. Any questions about that? Okay, well, does that look like a reflected version? Yeah. Now, if I translate, because in the original one, it's -4, which means it's translated 4 units in the negative direction of the y-axis, or it's translated 4 units down, isn't it? If I reflect that in the x-axis, does that translation still stay at -4? It should move and be reflected to +4, shouldn't it? Yeah? Because we're not reflecting just on top of where that graph ends, but along x-axis. So it gets reflected to +4, which is why we have a +4 at the end. Let us apply the f of x method. Of course, we start with f of x. That gets mapped to, now if it's reflected in the x-axis, it's a negative y value, or in other words, negative f of x, which is just y equals to negative of our original function. Or in other words, just our original answer, which I'm not going to bother writing, I'm just going to draw an arrow, because it's the same thing. Any questions? Okay, let's try our y-axis. So with our y-axis, similar process, except of course we're starting off with x, y maps into negative x, y. Can you read that up the back? I think my handwriting is getting progressively worse. Okay. So, reflects to that. We do the same thing, we say x dash equals to negative x, or if you're looking to speed things up, let's just skip right ahead and just write that x equals to x negative x dash. Because why not? Y dash, so y equals to y dash. And we have our new equation of y dash equals to the root of negative x dash minus 3 minus 4. Note that I did not touch the negative 3. I've just substituted x as negative x dash. Using our f of x method, f of x maps into f of negative x, which would get us the same answer anyway. Whichever one you're more comfortable with. If you're more comfortable with substitution of our coordinates, that's fine, you can do that. If you're more comfortable with our function notation, f of x, f of whatever it is, then you're welcome to do that as well. Okay, I know I've been talking for quite some time. I'm going to quickly move on and finish off dilation and then let you guys get started. Sounds fair? Okay. Last one, dilation. So the final type of translation we're looking at is transformation, I should say, is dilation, which stretches the graph, right? We can either stretch or compress it from the graph. So you guys already know what dilation is, right? We're essentially stretching and squishing, right? And depends which axis we're looking at. Here we go, dilation of factor A from the x-axis will increase or decrease the graph vertically, right? If it's from an axis, think that you're dragging from that axis. So for example, if it's dragging from the x-axis, you're dragging this way. But also another terminology you can use is along the y-axis, which is why it gets so confusing. So from the x-axis and along the y-axis mean the same thing. And alternatively, from the y-axis and along the x-axis also mean the same thing. Double check that you've interpreted the question correctly. Apologies, I'm going to jump straight into the examples. In this case, we're determining the rule of the image sketch and sketch the graph. I'll leave the sketching the graph for later. Y equals to 1 over x squared, dilated by a factor of 4 from the y-axis. So, dilated for a factor of 4 from the y-axis. From the y-axis, which way am I stretching it? From the y-axis. So starting from the y-axis and we're stretching it. So we stretch away and it should look like that. Okay, or along the x-axis. So I'm going to use my method, coordinate mapping. If you'd like me to go through coordinate mapping in a moment, I'm happy to, but I'll go through it afterwards. F of, now if it's along the x-axis, remember I do the opposite. It's not 4x, it's a quarter x. Okay, just like our translations. Y equals to 1 over a quarter. I'm going to do this instead. Why is this wrong? Go for it. Jetty, yes?
Yeah.
Go for it.
You're supposed to square the quarter times x.
Thank you very much. We're substituting x for a quarter x, which means that the x should be inside and the square on the outside there. If you simplify that, that becomes 16 over x squared. Great. Let's move on to the next one. It says from the x-axis, which means we're stretching this way. We're dilating that way along the y-axis, which means we just multiply a function. 4 times f of x, which equals to 4 over x squared. Any questions?